So we have another example with two statements, two inequality statements, and they're joined with the word and. So it's a compound inequality. It's like the other ones. But hopefully we'll get to practice a few more things here. Okay, so in the first one, the first statement, I'm going to add 3 to both sides. Squeeze it in there. I get 1/4 x is greater than or equal to 2, because negative 1 plus 3 is 2. And I want to get rid of that 1/4. So I can think of either multiplying by the reciprocal if it's a fraction, or you could just multiply by 4. That would be fine too. But I'm going to do that to both sides. It's a positive 4, so I get x is greater than or equal to 8. And so I want all the numbers. Here's 0, here's 8. I want all these numbers, the ones that are greater than or equal to 8. And that's how the graph works. Square bracket on the 8 because it's got the equal to part. So remember, if it's greater than or less than or equal to or greater than or equal to, use square brackets. Less than would go that way, greater than would go that way. And if it's just less than or greater than, use parenthesis this way or parenthesis that way. Okay? All right. So we got the first one then. Now we're going to have to distribute that -3, right? Okay, so -3x plus 6 is greater than or equal to 2. We're going to subtract 6. -3x is less than or equal to -4. And now we're going to divide both sides by -3. Okay, finally we get to divide by a negative number. So x, I have to switch my sign the other way, is greater than or equal to 4/3. Okay? Make sure I did all my math right. I think that looks okay. Now notice that that's the big switch there, right there. Why did we switch it the other way? Because we multiplied or divided by a negative number. So if you think real quickly, 5 is less than 10, right? But if you multiply both sides by -1, so -1 times 5 and -1 times 10, then you can't say -5 is less than 10. I'm sorry, less than -10. No, you have to say, so don't do that. You'd have to say -5 is greater than -10. So that's why we're switching the inequality when we multiply by a negative number or divide by a negative number. You have to switch the inequality the other way. So this one's yes, -5 is greater than -10. Okay, so you can think about that if you're wrapping your mind around it a little bit, but that's the rule that we have. Okay, so here's the graph of just this part. Here's 0, and we're saying greater than or equal to 4/3. Well, there's 1, there's 2. So 4/3 is going to be maybe about there. Greater than or equal to square bracket and off this way. So we want the numbers that are greater than or equal to 8, and they're also greater than or equal to 4/3. So it's got to be the numbers greater than 8. Okay. So you could line them up and match it again. You know, if you put it down here, that's probably what I should have done. And 4/3 is like over here. But see, they're not matching up until you get to 8. And it has to be and. Both statements have to be true. So the numbers we're talking about, they have to be greater than or equal to 8, and they also have to be greater than or equal to 4/3. Well, all the numbers that are greater than or equal to 8 are also greater than or equal to 4/3. So we just need the numbers, in this case, that are greater than or equal to 8. And so here comes the graph. It says graph the solution. That's the graph. And then write in interval notation. So it's going to be square bracket. Remember, we write our interval notation based on the number line from left to right. So we start with the smallest number, which is 8. That's our smallest number in the group. And we're going to include that 8, so it's a square bracket, comma, and we're going off to infinity. Infinity and beyond. Okay. Infinity, negative infinity, always get a parenthesis. I don't like it when they use 8 in infinity. It looks like the 8 fell over, but it didn't. Okay, I got 2 more problems. Okay, so another way they could write these sometimes is with what's called a compact form. So we're still making 2 statements. We're saying that this 3x minus 7 has to be greater than -4, but it's greater than or equal to -4, but it's got to be less than 8. Okay, so it's going from the smallest number, and then it's got a variable in the middle, and then another number on the right. So it's in 3 pieces. And what we can do to solve this is we can work with all 3 pieces at once. It's like the hockey of math. I always say that because hockey has 3 periods instead of usually, games have halves and quarters, but hockey has 3. Okay, so here we have our x in the middle, 3x minus 7, and we're trying to get x by itself still, but we're going to go ahead and add 7. Because we added 7 to the middle, we also add it to the first part. Oops, we add it to the first part, and we add it to the last part. So now I get the statement 3, and this is a double inequality. It's a compound inequality. It's just in a compact form. So 3x is less than 15. Now you could write 2 statements separately, but I think it's easier just to do them all at once. It's the same steps. So we're going to divide everything by 3. 1 is less than or equal to x is less than 5. And I call this the in-between situation, right? X is between 1 and 5. It can equal 1, but it can't equal 5. So it's saying x is greater than or equal to 1, but also and less than 5. So on the number line, it's pretty easy to do the graph because it's all there for you. Here's 0, here's 1, 2, 3, 4, 5. So we're saying we want the numbers that are greater than 1 or equal to 1. That's why the equal to is getting the square bracket. And then less than, so parenthesis on 5. And we want all those numbers in between. Infinite number of numbers in between. And that's a way to show it on the graph. The interval comes from the graph. Bracket 1, comma 5, parenthesis. That's the interval notation. Okay? Now you might be saying, wait a minute, well, what about back here? What if I had to divide by a -3? Well, we'll see if we get that situation. I don't think we're going to get it on the next one. But if it comes up, we'll deal with it. You just switch both inequalities, but we'll worry about it when it comes. Okay, solve the compound inequality graph and the solution, write the solution interval notation. Okay, so we're going to go ahead and add 1 to all 3 parts. We get -4 is less than or equal to 4x is less than 8. Divide everything by 4. -1 is less than or equal to x is less than 2. So what does that look like on a number line? Well, here's 0, here's -1, 1, 2, here's 2. So we want bracket, square bracket on the -1, parenthesis on the 2 again. They don't always work that way, but that's what we have this time. And that's what the graph looks like. Then to write an interval notation, square bracket -1, comma 2, parenthesis, there's the interval notation. So hopefully these are getting more fun. You can have 2 brackets, you can have 2 parentheses on these. I kind of like the in-between ones because it's telling you, hey, it's in between these numbers. Okay.